Hello ladies and gentlemen, welcome to my YouTube channel. Today we are continuing with our series on Maths Paper 2 that was written by November 2025 candidates. So I've uploaded the solutions from number 1 up to number 8. In this video, we are going to focus on number 9, which was a question on functional graphs. So it is reading, answer the whole of this question on a sheet of graph paper. The following is an incomplete table of values for the function y is equal to 12 over x. We are required to find the value of m and the value of n. So this one is a complete question on substitution. For us to find m, we are going to substitute 1.5 on x. So let us find the value of m first. So we are saying this is number 9a, part 1. We want to find the value of m. So we say m is equal to 12 over x, and then on x we substitute 1.5. So 12 divided by 1.5, we are going to get our m as 8. So this is going to be the answer on m. And then we are now required to find the value of n. We say n is equal to 12 over the value of x that we are going to substitute, it is 5. So 12 divided by 5, we get our n as 2.4. So this is how we get the first 2 marks in the question. Let us scroll up to see what was examined on the second part of the question. So let me write here. On m, we managed to find our m as 8. And then we managed to find n as 2.4. And then after that, use a scale of 2 centimeters to represent 1 unit on the x-axis, and then 2 centimeters to represent 2 units on the y-axis. We are required to draw the graph of y is equal to 12 over x from 1 to 6. So this is very important. We need to make sure that we follow the scale that is provided on the question paper. So let me show you how it is going to come out. So here, let us scroll down and go to our graph paper. So we are saying 2 centimeters to represent 2 units in the y-axis, and then 2 centimeters to represent 1 unit in the x-axis. So this is how we are going to draw our graph. This is our 12. Our 12 is here. And then we have our 10. We have our 8. We have our 6 here. This is our 4. This is our 2. And then this is 0. And then we need to come to the x-axis. We are having 1. And then this is 2. This is 3, 4, 5, 6. And we underline like this. And then we underline here like this. And then after that, we now need to complete our table. So we need to plot the coordinates. The first coordinate that we are going to plot, it is 1 and 12. 1 in the x-axis in line with 12 in the y-axis. So we need to plot that point. 1 in the x-axis is in line with 12 in the y-axis. So this is the point. we are going to plot this point, right? 1 in the x-axis in line with 12 in the y-axis. Let us look for the second coordinate. In the second coordinate, we are having 1.5 and 8. 1.5 in the x-axis in line with 8 in the y-axis. So we need to plot that point. We are saying 1.5 in the x-axis in line with 8. So this is our 8, and then 1.5, it is here. We count 1, 2, 3, 4, 5. It is here, right? And then we need to see the next coordinate. The next coordinate, we are having 2 and 6. 2 in the x-axis in line with 6 in the y-axis. 2 and 6. 2 and 6, it is here. So we are going to plot this point, right? And then the next one we are having 3 and 4. 3 in the x-axis and 4 in the y-axis. So roughly it is this point. Right? And next we are having 4, 3. Let me confirm. 4 in the x-axis in line with 3 in the y-axis. So we are going to plot this point. We are saying 4 in line with 3. So 3, it is in between 4 and 2. So it is 1, 2, 3, 4, 5. So we are saying 1, 2, 3, 4, 5. It is somewhere here, right? 4 and 3. Let me restart again. Something went wrong here. Let me restart again. So we are saying 4 and 3, right? So 4, let us count 1, 2, 3, 4, 5. Oh, it's okay, right? And then we need to plot the second point. We are having 5 and 2.4. 5 in the x-axis and 2.4 in the y-axis. So it is roughly this point. And then finally, we are going to plot 6 and 2. 6 in the x-axis and 2 in the y-axis. So it is this point. And then after that, we need to join these coordinates to come up with our cave. Let me join. I'm going to join like this. So I'm going to join like this. So this is going to be our cave. And then after that, we need to label our cave. That this cave is known as, let me label it. It is known as y is equal to 12 over x. So this is how we get the 3 marks on the second part of the question. Let us proceed to the next. So we are now in the next part of the question, where we are required to use the graph to find the gradient of the cave at x is equals to 3. So this is our x is equals to 3. This is our x is equals to 3. We are going to have our x is equal to 3 here. And then after that, we need to draw a tangent at this point. It is a line that touches the cave. So let me draw it. So this is going to be our tangent. And then after that, we need to find the gradient of the tangent. We say it is change in y over change in x. So we just need to select 2 of the coordinates. I have used 3, 4 and also 2, 5.6. So let us now calculate the gradient. So we are going to say this is now part C, right? We say gradient is equal to change in y over change in x. So we select N2 coordinates that are lying on our tangent. I have selected 3, 4, and also I have selected 2 and 5.6. So we say change in y over change in x. Change in y, we say 5.6 minus 4. And then change in x, we say 2 minus 3. And we are going to get our gradient is negative 1.6. This is going to be our gradient. And then after that, let us scroll up to see the next part of the question. We are now required to find the area of the region bounded by the curve, the x-axis, and the lines x is equal to 2 and x is equal to 4. So we need to understand the region that is required for us to find the area. So we are saying area of the region bounded by the curve, the x-axis, the lines x is equal to 2 and x is equal to 4. So let me show you the region that is being described. So this is our x is equal to 2, right? It is our x is equal to 2, and then our x is equal to 4. It is this one. This is our x is equal to 4. So we are required to find the area, this area bounded by the curve, the lines x is equal to 2, and also the line x is equal to 4. So we are required to find the area of this region. So can we say that we are having these complete squares, right? We also have this one. So we don't need to count here. We just say it is equal to 300 small circles. And then after small squares, right? And then after that, we count here to find the total number of small squares, right? So I have calculated and I managed to find 415 small boxes. So this is how we are going to find the area. We are now on the part that is required for us to find the area. This is part C, part 2. We say area. I managed to get 415 small boxes. So it is 415 over 100. And then we need to see the scale that was used. It is 2 centimeter to represent 1 unit in the x-axis and 2 centimeter to represent 2 units in the y-axis. It means that the complete box, which is having 100 smaller boxes, it is equal to 2 square units. So we say 415 over 100 times 2 square units. So we are going to get our answer is 8.3 square units. This is going to be our answer on the C part 2, right? And then after that, let us scroll up to see the next part of the question. D part 1, on the same axis, draw the graph of y is equal to 3x plus 1. So for us to draw the graph of y is equal to 3x plus 1, we need to create a table of values. So this is how we are going to create the table of values. So this is our table of values. Right, and then here we put our x, underline here, and then our y. Then we need to find at least 2 to 3 coordinates, right? So our equation is saying y is equal to 3x plus 1. So when x is equal to 0, if we substitute 0 on x, we are going to remain with y as positive 1. So this is going to be the first coordinate. And then after that, let's say we substitute 1 on x, right? We say 3 times 1, 3 plus 1, 4. So this is going to be our second coordinate. And then let's say we substitute 2. We say 3 times 2, 6, 6 plus 1, 7. So we need to plot these points on our graph. And then after that, we join them with a straight line, right? So the first coordinate, it is 0, 1, 0 in the x-axis and 1 in the y-axis. Let us go and plot that point on our graph. So we are saying 0 in the x-axis and then 1 in the y-axis, right? So it is this point that we are going to plot. We are going to plot this point. Next, we are having 1 and 4. 1 in the x-axis and 4 in the y-axis. It is this point, right? Next, we are having 2 and 7. 2 in the x-axis and 7. So 7 is roughly here, right? Next is 3 and 10. It is this point. After that, we need to join the coordinates by a straight line, like this. Right, and then after that, we name this line that it is y is equal to 3x plus 1. Right, so this is how we answer the next part of the question. And then after that, lastly, we are now required to hence use the graph to solve the equation 12 over x is equal to 3x plus 1. So there's a point where the curve and the straight line are meeting. So we need to write the x coordinate where they are meeting. So they are meeting here. This is where they are meeting. They are meeting here. This is 1.9, right? So when we are now writing the solution, we are going to write that x is equal to 1.9. This is going to be our answer on the last part of the question, part D. So that was all about the functional graph that was in November 2025. Let me show you the one I have drafted on the actual graph paper. It was like this one. So this marks the end of our tutorial on the functional graph that was in November 2025. Thank you so much for following me on this channel. Please don't forget to subscribe, like, and share my videos. If you want to join my WhatsApp classes, I'm starting with 2026 candidates on 1 November. And my lessons, I charge $10 per month per subject. I